So, good morning to everyone. Today we will see, in previous classes, we have seen the approach of the design analysis in the divide and conquer approach. We have seen the design analysis of algorithm. Today we will see another approach in the algorithm. Today we'll see the another approach, that is the greedy method. Now, in this divide and conquer approach, some algorithm follows that approach and performs their operation. We have seen. Same as that, some algorithms follows this greedy method approach. So before starting these algorithms, we will know what is the greedy approach or greedy method approach. Now, this problem or this method is basically used to solve the optimization problem. So through greedy method, we can solve the optimization problem. So now what is optimization problem? We will know that first. So like there is suppose a problem given that A is some place and B is another place. So from A to B, from place A to B, we can go through from A to B, we can go through by walking or by cycling or by using car or by using train or by using flight. So from location A to location B, we can go through by walking, by cycle, or by car, or by train, and or by flight. So these are what? These are 5 ways we can go from location A to location B. Now, there is some constraints given. A constraint is given that we have to travel from location A to location B within 12 hours. So this is the constraint given. Now, if we see this constraint, then we can see that location A and location B distance is such a way that we cannot go through by walking because it will take more than 12 hours time. Same as that, if we go by cycle, then from location A to location B, the time will be taken greater than 12 hours. Same as that, if we travel by car, then also it will take greater than 12 hours. That location A and location B is placed in such a distance. So that means we cannot take this way. So if we travel by train, then we can take this, or we can, if we travel by what? If we travel by flight, then we can also that we will within the 12 hour we can reach our destination. So that means what? This two way can we determine that if this two way or two approach we follow, then this approach is what? This approach is our constraint is followed. If by taking the constraint or by taking the conditions, this two way can be what? This two way can we take. So that means what? That these two solutions are called the feasible solution. So that means if we convert it into the real life problem, that means some problems will be given. Now this problem can be solved in many ways. This problem can be solved in many ways, but a constraint should be mentioned or a condition is given. So this condition is given. If the condition is given and we have many solutions present, but those solutions which is satisfying the condition, we will choose that solution. But otherwise, the other solution, we will do not consider it. Now, those solutions which satisfying the conditions, we set that some conditions we set, and this solution is satisfying that condition. That means we can choose those solutions. So these solutions are called feasible solution. So that means in real life, there is a problem, and in this problem, different persons' approach is different. They solve this problem in different ways and get the solutions. But we get many solutions for this problem. But what we will take? The solutions which is satisfying, we are maintaining our conditions. We are defining some constraints or defining some conditions. Those solutions which is matching those conditions, we will take that solution only. Same as that in problem, what we have said that from location A to location B, they are going through the 5 ways. But in 5 ways, we have set a constant that within 12 hours from location A to location B, we have to reach. But if we take some, we can see that if we by walking, we will take, it will take what? It will take greater than 12 hours. But if we go by cycle, then it will take greater than 12 hours also. And if we take by car, then it will be what? It will be greater than 12 hours also. But only 2 conditions that is following these conditions, that if we take by train and if we take by flight, then we can reach within 12 hours. So that means what? These 2 solutions are satisfying the condition. So that means we will choose those solutions, or we can say these 2 solutions are what? These 2 solutions are the feasible solutions. So this is what the feasible solutions of problem. Now, in this feasible solutions, what we can say the optimal solution. Now, optimization is a problem which requires either minimum result or we can maximum result. A problem which requires either minimum result or maximum result. Now, if we take some properties that we can say that both by train and by flight, we can reach from location A to location B within 12 hours. But we want to think that we have using some minimum cost, we can reach there. So if we take those solution, and from this solution, if you take that by train, the cost will be low. So that means this condition by train will be the optimal solution. So that means every problem, there must be one optimal solution. So a problem which requires either minimum result or the maximum result. So we have said that these solutions, we get 2 feasible solutions. Now some properties are given, that is maximum or minimum. The properties is given maximum, that optimization problem says what? That problem requires either minimum result or maximum result. Now we are taking the properties of minimum. So properties of minimum, we have said that we have to take these, both solutions can be feasible, but we have to take minimum cost, means minimum result. So if we take from both these solutions, the minimum cost will be what? By train, if we travel, then the cost will be minimum. So what is the feasible solution? Feasible solution is these 2 solutions we get. But what will be the optimal solution? The optimal solution will be based on the minimum cost. So by train. So by train means this is the optimal solution. Now in real life problem, there may be more than feasible solutions present, but we have to using some properties, minimum result or maximum result, minimum some properties, we have to determine what is from this feasible solution our optimal solutions we can get. So every problem in real life, there must be one optimal solutions present. This is the idea. So by explaining this example, I am giving the idea that which is optimal solution and what we call the feasible solution. So till now, it is clear that what is feasible solution and what is optimal solution. It is clear to everyone?
Yes, sir.
Yes.
So there may be more than feasible solutions, but only one optimal solution should be present. Now this optimal solution will be done by either by minimum result or by the maximum result. What we should determine, it will be determined by us, that what it would be. Okay, so a problem which requires either minimum result or maximum result, this will be called the optimization problem. So now the strategy to solve the optimization problem. So for solving the optimization problem, there are 3 properties or strategy we can follow. These strategies are greedy method, dynamic programming, and branch and bound. So these are some strategies. So our first strategy which we will discuss, that this will be the greedy method. We will discuss the greedy method strategy. So first we will know what is greedy method strategy. Now greedy method says that a problem should be solved into stages, and in each stages we consider one input from the given problem, and that input is feasible. That input is feasible, it will be included in the solution. So by including all those feasible solution inputs, we will get the optimal solution. Now, in simple words, we can explain that what it is. If we say that a real life example will take that in interview of any company interview, that you goes from this company interview, there are some rounds. That first there is an aptitude round. So like this company's advertisement is released and 1,000 applicants have applied for that company. Now there is only one post for that company, but 1,000 applicants have applied for this only one post. So what we will do, the company will use some own methods for screening. That means use some methods for screening. That is, company said first that it will take some aptitude test. So now the students or the applicants, they will give the aptitude test, and from this aptitude test, some candidates will be selected and some are rejected. So those students who will selected will go to the next rounds, and in this next round is the there will be the GD round. From there also, from 1,000 students, 500 students are selected. Let's say that 500 students are selected and 500 are rejected. So that means 500 students are selected for this. So in the next round, that is in this next round, this 500 student will give this 500 student will give our group discussion test. So from this group discussion test, 250 students are selected and 250 students are rejected. So these 250 students who are selected will then go for the final round interview, technical interview and HR interview. So from there, these 250 students, from these 250 students, only one students are selected, and they are he or she is selected for the post. Now, this is this is the greedy method. Greedy method means that greedy method says that a problem should be solved in stages. Now you see, this is there is first an aptitude test. In second stage, there is an in second stage, there is our group discussion test, and the third stage, this is the final interview, that is technical and HR. So that means this is the greedy way. Greedy says that a problem should be solved in stages, and each stage we consider one input from the given problem, and that input is feasible or it will be included in the solution. Now, at first, the students are selected. From 1,000 students, 500 students are selected and 500 rejected. That means in this stage, this 500 is this 500 are feasible. They think that this 500 are feasible. So this 500 are selected and this other 500 are rejected. So in that stage, it is this 500 are selected. Next, after this, our group discussion round, from this 500, 250s are selected and 250s are rejected. That means in that stage, these 250s are feasible and these 250s are These other 250 are rejected. That means they are not feasible now. So in each stage, we consider the input problem, and this input is feasible. So if the inputs are feasible, it will be included in the solution. So these 250 are These 250 applicants are now included in our solution. So that means are included, that they think that in this stage, these 250 students can be we can take them our technical interviews, and HR interviews. They are feasible. I think that these applicants are feasible for my company. So now, after this stage, what? After this stage, what we have do? We have done this 250 candidate. From this 250 candidates, one candidate is selected and others are rejected. So that means what? We get the optimized. We get the optimal solution. Optimal solution we get. So that means what? This is what the greedy approach, that in each stage we consider one input from the given problem, and if the input is feasible, it will be included in the solution. So by including all those solution inputs, we will get what? The optimal solution. That means the 1% which is selected for the company is the optimal solution. So this is what the greedy approach. But if you do not follow the greedy approach, that there may be some student or the applicants complain that I am the screening method is not right. I am maybe selected, but they have not selected me. But if you think that the company has set some standards, the company has set some standards, and in that standard, in each standard, the what he said the standard, this person is what? This person have those who the person who is selected are what? Satisfy that conditions which the company selected. So that means what? The approach is right for me, means the approach is right for the company. But there may be students think that why I am not selected. Then for that reason, what you have to do? This 1,000 students have to sit in what? This 1,000 students have to sit in the aptitude test. Then this 1,000 students should again appear for the group discussion test. Then this 1,000 students should again appear for the what? The final interview or technical interview stage. And from them, we can select the person. So that is what, if we take this, then our solution space will be large. That's why what we have done that the company have done that filtering process. So greedy method is that each stage this filtering process will work, that those inputs which will be feasible will be taken, and those inputs which are not feasible in that time, it will be rejected. So, and after doing this process, we will get what? We will get the optimal solution. So this is the way greedy method follows, or greedy approach is that. Clear?
Yes, sir. Yes, sir.
Yes, sir. Okay. So this is what the greedy approach. Now we will see a simple algorithm of the greedy method. Now in this algorithm, you can see this is the algorithm. We are naming that algorithm greedy, and it is taking two inputs. That is the array and the size of the array. The array we are taking, for which we have within this array some elements are present. So we are considering this array, and the number of elements present will be n. So we will check what? From 1 to n. Here I have used 1, but if you use 0, then it will be for I equal to 0. But I have used 1, so that means for I equal to 1 to n. So for I equal to n, I equal to 1 to n, do. That means what? In this loop, inside this loop, there is x equal to selected. So that means 1 by 1 input will be what? Selected. So in the array, the elements present will be selected 1 by 1. And if the what? If the element which selected are feasible, then what we will do? We will put into the solution. So that's why it is given if feasible x. That means the element which is chosen are stored in the x. So we will what? We will check that this element is feasible or not. If it is feasible, then it will be added into the solution. So that is the what? that is our in the array, if they are in inputs, so we'll take the inputs and check if this input is feasible, or if so, that is basically that if we do some problems and we get some output, so we will check that output one by one, that this output is feasible for our setting some constant. We have set some constant, and if this output is followed that approach or the following that condition, then it will be what? It will be inserted into the solution. Otherwise, we will reject that. So this is the algorithm. This is the algorithm of greedy method. So in this greedy method, the algorithms follows the greedy method. The first algorithm which will know that the algorithm which follows the greedy approach is the knapsack problem. The knapsack problem. This knapsack problem follows the greedy approach. Now, it may happen that a problem, it can be what? It can follows greedy approach, the strategy we have used for some optimization problem, that there may be some problem which follows greedy method, dynamic programming, and branch and bound. Or there are some algorithms present which only follows the greedy method, or the algorithm that follows the dynamic programming approach. So there may be some algorithms that follows what? This that can follows this all the our strategies. But there may be some problems present that only follows the greedy approach. So for solving that problem, we can only follows the greedy approach. It may happen. It may happen based on conditions or based on the solutions, or it based upon that. So first, the thing we will see is our knapsack problem. So giving definitions of the knapsack problem, that is what we say that knapsack problem, what we can say, the in knapsack problem, or we can say it is a rucksack problem, that there may be a back present. So there may be what? There may be like a back present. So in knapsack problem, or we can say the rucksack problem, we are given a set of items. Means some items will be given. In the knapsack problem, some items will be given, where each item has some weights and each item has some profit. So our what? Some items, some n number of items will be given, and this n number of items is what? Or if in this n number of items, our items weight and value will be given. Now we have to there determine a subset of items to include in a collection, so that the total weight is less than what? The total weight is less than or equal to the given limit, and total value is large as possible. That means there will be some n number of elements present, and this n number of elements, profit and weight will be given. Now, there will be a bag, or we can say this bag as a rucksack or knapsack, the thing. So this bag is what? This bag has some weight. This bag may have some weight determined. So if there will be some objects present, so consider that there is 7 objects present, and these 7 objects had some different weights, and this bag has had what? This bag has total weight 15 kg. This bag has total weight 15 kg. So what we have to do? We have to select the items which is given. We have to select the items, because if there is number of elements are greater, then we cannot take all the elements into the bag. So how we will determine which elements we will choose or which elements we will reject it? We will choose such a elements, because if there will be 2-3 elements present and their weights are what? If we total calculate that weight, that means their weights after total calculation of these 3 elements weight, it is less than 15 kg, then what? We can directly input it into the bag. There is no problem. But if the objects are greater than, that means if the number of objects are greater, if the number of objects are greater, then their weights, the total combination, if we take all this objects weight, if we consider all the objects weight, then it will be what? Its total weight will be greater than the bag, or the bag is given that's greater than the weight of the bag. Then we cannot take all the elements into it because bag has some limit. Then how we can choose which element we will put in the bag or which element we will reject it? Now there is a trick that we have to choose such an element. We have to choose such elements whose weight, by such taking weights, we have to get the maximum profit. We have to get that this bag will be traveled from another space. In real life, this bag will be traveled to another space, and we have to sell. Like if we have to sell these items that is put into the bag, we have to sell these items. So sell these items, that which items we will put into the bag, that those items which profit is much. Now, this is the trick, that we have to put the elements. We have to put the elements in such a way that its weight shouldn't concede the total weight of the bag, but we get the maximum profit. So this is the main approach, or this is the main way of the knapsack problem. Knapsack problem says that we have to put the items into the bag if that bag, the limit of the bag is given. So that means we have to put the elements one by one into it. Put the elements into one by one into it. Then such weights should be included that give the maximum profit. Now you say that if we choose total weight of some elements, then we didn't get the maximum profit. That's why this knapsack problem has two type of knapsack problem is that. One is fractional knapsack and another one is 0-1 knapsack. So in case of 0-1 knapsack, we will choose the item or not. If we choose these items will be directly included in the bag, and if we either didn't choose that, then it will be not included in the bag. But in case of fractional knapsack, what we will choose? We'll choose some fractional weight also. That all weights of the element, we will not choose that fractional knapsack. We will choose what? Fractions of the weight. So by defining these fractions of the weight, we'll put it into the bag, and what it will do? We will, from that fractional, we will get the maximum profit. So this is what our knapsack problem states. So there are two types of knapsack problem, that is fractional knapsack and another one is 0-1 knapsack. Clear? It is clear to everyone?
Yes, sir.
Okay. So now I will share the QR code with you. So give your attendance. So I am sharing the attendance. So everyone, give your attendance by scanning this QR code. And in next day, today it is up to this. In the next day, we'll discuss about what? The next day, we'll discuss about our 0-1 knapsack problem, and through greedy method, how we can solve this knapsack problem. We will see in the next class. Okay. So everyone, it is clear the thing, what approach that this is like. There is another approach which you have seen, divide and conquer approach. This is also another approach. So there in this algorithm, there will be multiple approaches present, and the algorithms that follows these approaches. Clear?
Yes, sir.
So if you see in the syllabus that the 2 modules are completed, in the, some modules I have not the heap sort. In a module there is a heap sort, but I have not discussed that. This heap sort will be some after some algorithms we will discuss about the concept of the heap sort. So if you see that already we have covered the 2 modules, almost 2 modules we have covered. So there will be the 5 modules. Now the main part of the algorithms will start, because we will see many algorithms we will see in it. So this part will be started. We will start one by one our algorithms. So everyone has scanned the QR code for your attendance?
Yes, sir.
Yes, sir.
Is anyone left? Is anyone left?
No, sir.
Okay. So then thank you everyone. I am ending the session. So next class we will discuss about that. Today I am giving the views how the algorithm works. So from next day we will see that the portions of the algorithm, that the algorithms calculations we will see in the next class. So thank you everyone. I am ending the session.
Thank you, sir.
Thank you, sir.